So, welcome everyone. It's a pleasure to demonstrate what we are doing here in the lab. This is called the food lab, where we produce a food product starting from these spores. So these are the fungi spores that we have. This is one strain called Aspergillus oryzae, and we have another strain here that is called Neurospora intermedia. So from these strains of fungi, we feed them with, it can grow on different materials, but for the food production, we use edible carbon source, something that is already eaten in the market. So for this current project, we are using oat flour that you can buy from the shops as a carbon source. And from this, we can produce biomass that is of higher nutritional values, and we can create something that is of, we call functional food. So from the beginning, we propagate these spores, and after that we feed the oat flour into this what we call shake flask, which is about 500 ml. And if you can see closely, we have already some little biomass that has been formed. And from this 500 ml of solution with biomass, we feed it into a 26 liters reactor that we will show later. And from the 26 reactor, we feed it into the big 1 cubic meter reactor. At the beginning of every process, we sterilize every material that we use, including the substrate in this case, and also all the glassware and every equipment that we use. We sterilize everything so that everything is clean for use, because we are working with food material. And after that, we will show you what we get at the end. We get some biomass that has formed on these spores, and then we can dewater that because we use medium that has a lot of water, and then we dewater the material, and we can store it in the freezer, and after that we can prepare the different food products that my colleagues will show you in the kitchen. Yeah.
So we can go to beside the reactor to explain more about the process. Yeah.
And before, again, we feed this reactor, we sterilize with steam. We have a boiler here. And this is 26 liters in total, but the working volume is about 20 liters. And if you can see closer, we have some bubbles already forming, because we have to provide the right conditions for the biomass to grow. And the most important conditions are the right temperature and the aeration. So we have to work at a particular flow rate. So if you can come closer, you can see some bubbles forming up here. And we can control the right kind of conditions using this computer system. And after that, when the biomass has grown for only 1 day, we can collect it, and then we feed it into this big reactor.
Yeah.
So the biomass that will form from this 26 liters reactor will be something close to how you see this biomass forming. And then we can again propagate it into the big reactor. So it's a sequence of scale-up that we have in this lab.
The first step, as my colleague told, for working with the reactors is the sterilization. So we sterilize this reactor in 2 steps. The first step, we sterilize the reactor when it's empty. For the second step, we transfer the media to the reactor, and then sterilize the reactor and media again. And then from the biomass that we get from this 26 liter reactor, we inoculate this 1 cubic meter reactor. I mean that the media from this, or biomass from this, used as a starter or pre-culture for 1 cubic meter reactor. After inoculation, the cultivation time starts. We adjust the aeration, and also we control the temperature here. And that's it, the cultivation starts. The other important things that we monitor during the process at different interval time is that monitoring the pH, weight of biomass, and also we analyze the media to see if there is any contamination in the media or not. We do this analysis with HPLC, high performance liquid chromatography. And at different interval time, we take a sample from this tab, 100 milliliter sample, and then monitor the pH, the weight of biomass, and this parameter. So if you are interested, we want to demonstrate you how we harvest and how biomass look like. Okay.
So this is the collected biomass. We have to use a sieve because it's a lot of water.
Yes, for removing the excess water, we use this compact sieve to collect the biomass. Then after that, we freeze this fresh biomass. And then for further using for making food or something like that, we dry this biomass.
So you can imagine from the small spores that we have, and then finally we have this that is edible. We can produce different types of foods with it. And I can also mention lastly, I think it's important to mention that this whole process, from the time we have the small spores until we have this biomass, it takes about 4 days. Yeah. So if you compare with other sources of food, like meat, you need several years to produce 1 kilo of meat. But here we produce a functional food in only a total of about 4 days. And it could, 4 days is the shortest time, but sometimes we can go maybe for 5 days. And from this 1 cubic meter, we have about 5 kilos of dry biomass. Yeah.
And the concentration of oat flour that we use for this process is 30 grams per liter.
So we take it through another one step of dewatering. So we press the biomass and remove more water from it. And then after that, we can safely freeze it. And when we want to use it as food, we can take it through a process of drying. We have some dryers in the kitchen. And after that, a colleague can now make different types of foods from it.
Yeah.
Yeah.